In this video we are going to discuss about the static registers and latches. On completion of this topic, students will be able to explain the SR latch and explain the universal gates and which gates are under the universal gates. So in SR latch, normally this SR latch has the static sequential component that relies on the concept that is cross coupled inverted pair, and also this SR latch has the static and the dynamic latches. So here this SR latch is nothing but set reset. SR latches are the simplest form of latches, and also it can be implemented using two inputs. Either it can be set or it can be reset. So the S input sets the output to 1 while the R input resets the output to 0. When both S and R at 1, the latch is said to be undefined state. So here you can see the SR latch NAND version. So when two inputs 0 0, the NAND output is 1 0 1 means 1 1 0 1 1 1 is 0. So here when he goes to the complementary word, if it is 0 and 0, if it is 0 and 1, that is 1 0, and if it is present and the input is given as 1 and 1, then it is present to be, since the input is the same, it goes 1 to q to 1 and q dash to 0, that is in hold state. And here if we give 1 and 0 as an input, then this goes to 0 and 1 state and it goes to reset state. Next, if the input is 1 and 1, then it goes to the 0 and 1, which is in hold state. So you can see the set, reset and hold state. So when the input is 0 and 0, it goes to same state, that is output is equal to 1 and 1, which we cannot be allowed. Next, the SR latch with the clock signal. So normally this SR latch is made up of the two NAND gates, and this SR latch is an asynchronous device which works independently of the control signal, and also it relies only on the state of the S and R latches. So the major difference between these latches and the flip-flops is this flip-flop is an edge trigger type of the memory circuit, while the latch is the level triggered type. It means that output of the latch changes whenever the input changes. So this latches is mainly used in the circuits like power gating and clock as a storage device. This is applicable for the asynchronous systems like input or output ports, and also they are used in the synchronous two-phase systems for reducing the transit count. And here if you see the D latch, so this D latch is nothing but this is used to capture or latch the logic level which is present on the data line when the clock input is high. So if the data on the D line changes state while the clock pulse is high, then the output Q follows the input D. So the only way to estimate the undescribed indeterminate state is the RS flip-flop is to ensure that the inputs are never 1 simultaneously. And this D latch in the case of the transmission gates, this is uses the two additional gates in the front of the basic NAND gates, and the input lines are usually clocked as clock or data. So the main function is to note the clock signal to be connected to both of the front NAND gates. So when C is equal to 1, TG1 closes and TG2 opens, that is Q dash is equal to D dash and Q equal to D. When C equal to 0, TG1 opens and TG2 closes, it goes to hold and Q plus. And next is flip-flops. So in the case of flip-flops, the latches are transparent in this. So if any changes occurs on the inputs, it is seen at the outputs immediately when C is equal to 1. So this goes in the asynchronous fashion. That can be it can be done in the asynchronous fashions. So this flip flops are synchronous circuits, and also it is also a gated or the clocked SR latch. So this circuit diagram, the clock can be changed, that is if the stored data is changed only when you give an active clock signal, otherwise it will be remains in the otherwise the data will not be changed until the SR will be in the active state. So this types of flip-flops of RS flip-flops and data flip-flops. And the next one is master slave configuration. So master slave configuration is nothing but when clock pulses in this when this clock pulse is high, the output of the master is high and it remains high till the clock is low. Since this clock changes from the toggles as long as the clock is high, making the circuit to be in unstable state. So this can be avoided by ensuring the clock signal at logic 1. And for this concept we have introduced master slave JK flip flop, which is nothing but the combination of two JK flip flops connected together in series configuration. Out of this, one acts as a master and other acts as a slave. The output from the master slave is connected to two inputs of this slave flip flops, whose output we can say that it is fed back to the inputs of the master flip flop. So in addition to these two flip flops, the circuits also includes an inverter. This inverter is connected to the clock pulse in such a way that it is given to the slave flip flop. So we can say the master flip flop is 0 pins. Next, the CP value of the slave flip flop is equal to 1. So here when the clock pulse goes to 1, the slave will be isolated, and JK flip-flops may affect the state of the system. So the state slave flip-flops is isolated until the CP goes to 0. When the CP goes back to 0, the information is passed from the master flip-flops to the slave and the output is obtained here. So first the master flip-flop is positive level and the slave is the negative level. If J is given as 0 and K equal to 1, we produce high output. If J equal to 1 and K equal to 0, high output of the master goes to the J input of the slave and the negative transaction sets to the slave. If J equal to 1 and K equal to 1, it produces a positive transaction of the output, and if J equal to 0 and K equal to 0, the flip-flop is disabled. So here you can see the block diagram of that. When C equal to 1, master is enabled, and C equal to 0, master saves the passes to the enabled to slave to go to the new data. And next one is the D flip-flop characteristics. So normally D flip-flops is mainly used for the transaction of one flip-flop, that is it is the most important from the other clocked signals, and it ensures that the same time both the inputs are never equal to 1. So here it is it changes the state of the output signal until the next rising edge of the clock of the signal changes. So first it defines the logical properties, and next Q of t remains the present state and Q of t plus 1 remains the next state. So you can see the characteristic table, that is if the input is 0 0, there is no change, 0 1 reset, 1 0 set, and 1 1 it is undefined. And the characteristic function, that is Q of for the present stage and the next stage. So if the present state is 0 and the next stage is 0, it is a set operation, and if it is 1 in the present state and next state is 1, it is reset. So D flip-flop timing parameters also change according to the rising edge of the clock timing until the input signal occurs. Gives questions on static registers and latches, difference between latches and registers. Thank you.